Hey, good morning, guys. Good job yesterday with the assignment. I think you guys did a nice job of looking at the notes and seeing what I did, and then transferring that to your own problems. So a lot of really good detail. A lot of people were very thorough, which is great. I think as we get more comfortable with this, we might start skipping some steps here or there just to kind of cut down on our writing. But whatever you're comfortable with, please continue doing so. Okay. Today's notes just are a little different starting out. The problem's going to be presented to us in a different way, but it's the same process. So, like, once we get to the point where we saw yesterday's problems were, then everything beyond that is the same. Okay. So, we're still going to be using the sum and difference identities. Continue to refer to them, guys, because, as you can see, like, even though when you're adding two angles with cosine, when you expand it out and use the identity, it becomes subtraction. So there's little things like that you don't want to miss. All right. So the only thing we know to this point is what's called the sum and difference, meaning when you have two angles that are being added together or when one's being subtracted from the other. Then we can use these identities. But if you notice what you're given in this first problem here, the sine of 105, well, that's only one angle. Correct. However, if we can possibly make it two angles, then we can use our identities and we can use kind of what we saw yesterday in our notes. So what I want to think about, and there's more than one way to do this, is there another way to write 105? And I want to do so using our special angles. Like I wouldn't want to take an angle of 100 degrees and add it to an angle of 5 degrees. Sure, that equals 105, but at the same time, neither one, right, are special angles. That's not going to help us. So you want to think of special angles that add up to 105. So think about like your 30s, your 60s, your 45s, and not just those, but it could be 120, it could be 150, 100 and 180. It could be all our special angles that we possibly could use right now. The two that first popped to my head would be the sine of 45 plus 60. So when we think about this and we think about two different angles, two numbers that could add to 105, we have to make sure that they are, in fact, our special angles. 45 is and 60 is. 45 and 60 adds to 105. So now this problem looks like a problem from yesterday, and we carry it out the same way. I saw some of you skip this next step, which I'm perfectly fine with. You don't have to write it out. You could just kind of go to identifying, what is the sine of 45. I might do that in the next problem, but for this one here, I'm going to write it out. So I'm using our first identity up there. So it's the sine of A, cosine of B. So just think of it as like your first angle, your second angle. And then plus cosine of 45. And the sine is 60. All right, remember, when you're going through this, make sure you're thinking about the quadrants. Now, both angles are in quadrant 1, so that means we're going to have positive signs here. But the sine of 45 degrees, the y-coordinate of a 45-degree angle, is root 2 over 2. All right, times the cosine of a 60-degree angle, cosine of 60, or if you want to think about it as 60 degrees is pi over 3. But the cosine would be a half. All right, plus the cosine of 45, which is also root 2 over 2, and the sine of 60, root 3 over 2. Now, I didn't put parentheses around these, but continue to do so just like we did yesterday if you like to. But what I'm going to do now is just multiply these together. Right? I'm going to multiply the numerators. I'm going to get root 2. The denominator gives me 4. Over here we have plus the square root of 6. over 4. And rather than having two separate fractions, because I have the same denominator, I could just put it as 1. So root 2 plus root 6 all over 4. So not only will you be given angles in degree form, but we also have to work with them in radian form. All right, so we have to think about fractions here. Now, what I would suggest doing is thinking about these fractions with denominator 12, then thinking about, can they reduce to a special angle? Like, for example, and you can do addition or subtraction. You know, the ones that first come into my head here would be, well, how can I get 7 pi if we took 3 pi over 12? So 3/12, right? 3 pi over 12 plus 4/12, 4 pi over 12, gives us 7 pi over 12, right? Now, we might not think that those are special angles, but it helps first off by us making sure that they equal what we're given, right? The sum of those would equal 7 pi over 12. And now when I go to use the identity, and it's the addition one with sign, so it's the same one that we just used, I'm not going to write 3 pi over 12. I'm going to reduce, and I'm going to tell myself, all right, the sine of I meant to put a 4 there. So 3/12 reduces to 1/4, right? 4/12, 4 pi over 12, reduces to a third. All right. So again, first think about how you would write these as a sum or difference. So think about two angles that would add or subtract to 7 pi over 12. So keep that denominator if it helps. Then once you keep the denominator and you realize, yes, these both add to 7/12, well, now do they reduce or do they simplify to special angles? All right. And both of these did. So at that point, I can now continue expanding this out. So cosine of A, which was my first angle there, which is a fourth, and the sine of B, which is a third. All right, again, these problems I'm just pulling off the worksheet that I'll also give you. All right, and this was number 1 and number 3. Now, coincidentally, the angles that I chose to use in both of these happen to be the same angles. So these are the radian form of both 45 and 60 degrees, right? So my answer is just going to be the same exact thing here. Like if I were to ask myself, well, what is the y coordinate of pi over 4? It's root 2 over 2. What's the x coordinate of pi over 3? It's a half. Okay, so your answer to number 3 is going to be the same exact answer for number 1. We just started out in a different way. All right, so I'll try to save some video time here. I'll make this a little shorter. I won't write all that out, but you can pause it if you need to, but it's the same thing. It's just this happened to be in degree form, and number 3 was in radian form. All right, 11 pi over 12. Now, it wouldn't make sense for us to use 10/12, though that does simplify to 5/6, which is a special angle, plus 1/12, right? Because 1/12 is not a special angle. So we have to come up with something, two angles that do in fact reduce to special angles. We can't get anywhere with this. So think about 11 pi over 12. How can you get 11? And you want to think about it in ways in which you know that those two angles will reduce to special angles. All right, so keep thinking. I'm just going to kind of set us up here. So you should be thinking about two angles that you would use that would reduce to special angles that would give us 11/12. So again, I'm just setting this up. Now, in your thought, you might have come up with angles that would subtract to give you 11/12. I thought of ones that are going to add. All right, so I'm going to use 8/12. All right, 8 pi over 12, because I know that reduces to 2/3. And I'm going to use 3 pi over 12. All right, so 8 and 3 add to the 11, which we need. But I knew that these were special angles. All right, so again, these aren't going to get us anywhere. These will. All right, so I'm going to have to use my cosine, right? The sum of the cosine identity. So over here, the sum of the cosine identity, I got to know when I set it up, I'm going to subtract. So it's the cosine of 8 pi over 12, but we're going to put 2/3. We're going to reduce it. And the cosine of pi over 4. Minus the sine of A and the sine of B, so the sine of 2/3. This was the part that I was saying you could probably skip this. If you wanted to cut back on your writing, you probably don't need to do this. You could probably just say, all right, well, what is the cosine of 2/3? All right, or what is the sine of 2/3? That might save you guys some time. All right, so I set it up using the identity. This is a problem where we're not in the first quadrant, right? Well, we are for the one angle, but not for this angle here. 2/3 is in quadrant 2. And x in quadrant 2 is negative. So I got negative 1/2. Pi over 4 is in quadrant 1. This is going to be a positive root 2 over 2. The y-coordinate in quadrant 2 is positive, and the y-coordinate is going to be root 3 over 2. And the y-coordinate here is root 2 over 2. All right, multiply these out. And just like you saw yesterday, and I hope you guys kind of understand why, but you continually get the same type of answer. And the reason for that is because we're multiplying and we're adding and we're using special angles. And as we know, those points, right, don't change other than the fact their signs might change. So my final answer here would be me just putting that as one fraction, so negative root 2 minus root 6 over 4. All right, and that's it. So guys, hopefully today you watched this video again. Thanks again for watching the one yesterday and doing all the work. I'll try to get back to you guys with some feedback today. But yeah, enjoy your day. All right, hope everybody's doing well, and talk to you soon.